All right, with this video, we're going to take a look. Oh, got the hiccups. Great. It's going to be a fun video. Okay. With this video, we're going to take a look at the volume of prisms and cylinders. Gosh, this is going to be hysterical. Okay. Oh, wow. This is going to be a lot of fun. All right. The big idea. So big idea. Oh, I'm going to do a whole video with hiccups. When it comes to prisms and cylinders, the big idea, it is the area of the base times the height. So volume is going to be area of the base times the height. So we need to get some things sorted out here. First things first, we need to understand some stuff. Let's start off with this guy, the rectangle. So here, rectangular prism, right? I have two identical bases and the hiccups. So this base. So if I want to find the volume, right, the volume of this prism, I need to calculate the area of the base and then multiply it by the height. This becomes a bit of an issue, right? Because if I put this up on the board and I said, find the area of this, you would say base times height. Base times height times height. You can only have one height. So for rectangles, we need to change the way we think about it a little bit. When it comes to the area of a rectangle, I want you to think about this as length times width, right? Or length times width. Either way, doesn't matter. Which one's length, which one's width, it doesn't matter. It's really irrelevant. What is relevant is trying to get rid of your hiccups, and making videos for your geometry class is not a great way of doing that. So area of the base times the height, but we have to change the way we think about it. We can't call it base times height for the area of the rectangle anymore. We need to think about this as length times width and then times height, right? Especially if you could try to sneak a hiccup in between the length times width and height. That would be really impressive. So length times width times height. Length times width times height. That's going to give us the area of a rectangular prism. The other big issue that we're going to come across, this guy, the triangular prism, right? So triangular prism, triangle on the bottom and top, prism in between, right? Prism. So area of the base times the height. When it comes to triangles in class, we've been saying it's 1/2 base times height. We got to be really smart about that. We can't say that this base and this height and then times this height. We can't use that anymore. So we have to change the way we think about it just a little bit. So for the area of the triangle, we're going to have to call it base. And then here we're going to call this right here, where it meets at a 90-degree angle. And you still have the hiccups and it's really annoying. And you're trying to make a video. You don't even care, right? Just you're still going to do it. You're going to power through. Instead of this being the height, we're going to call this altitude. So base times altitude will give us the area of the bottom, and then times the height. Okay, so that triangle now, instead of 1/2 base times height, the area of the triangle, we're going to call it 1/2 base times altitude. Okay, if you haven't noticed, the hiccups are very distracting and it's hard to talk, but hopefully you kind of caught on to the fact that we're not going to call this part the height anymore. We're going to call it the altitude, and that's going to come into effect whenever we look at trapezoids as well. Really cool stuff. All right, so here we go. For triangular prisms, Remember, area of the base times the height. Well, the area of the base is going to be 1/2 base times altitude times height. I'm going to be very careful here that we call this altitude, right? Not to be confused with apothem, right? Because as we're going to see here, whenever I have my regular polygons as a prism, right? This would be a, well, count them out. 1, 2, 3, 4, 5, 6-sided. Is that a heptagon? Hexagon. Thank you. So we have a hexagonal prism. A hexagonal prism. Okay. This, remember, the area of a hexagon is a base times apothem, right? Remember the apothem. So base times apothem, right? Times the number of sides divided by 2. Then we got to multiply it by the height. So we'll get to those guys here in just a second. All right. And carry on. So for triangle prisms, that A stands for altitude, or altitude, okay? For, oh, good gravy. For trapezoidal prisms, remember the area of a trapezoid, base 1 plus base 2 times the height divided by 2. Can't do that anymore. Can't call it height. We're going to have to call it altitude. So base 1 plus base 2 times A for altitude over 2, all of this times the height. And what's really nice is that the way math works is that I can put the height all up in the top. So for a trapezoidal prism, base 1 plus base 2 times the altitude times the height divided by 2. So here, again, this is altitude. Altitude or altitude. The hiccups made me misspell that. If anything, blame it on the hiccups. Okay, for rectangular prisms, as we talked about earlier, we can't say base times height anymore. We're going to have to call this length times width times height. And then when we get to, excuse me, let's see, oh yeah. Polygonal prisms. We have base times apothem times the number of sides divided by 2. But now we have to multiply it by height, so we can sneak that height in here too. And this is apothem. So I want to be very careful with the different A values that we have, the different A values. So let's do one. You know what? Let's do this. I want to start off with something a little bit more challenging. So let's start with our first example. Let's do this hexagonal prism. This one here, this hexagonal prism that we have. Super cool. All right, so what do I need? I need a base. I need an apothem. I need the number of sides and the height. Okay, that's the information that I need. So let's measure. Okay, measure. I got it, guys. It's okay. And we're also going to need a calculator because we're going to do some heavy lifting with the multiplication. Goodness gracious. Oh, these hiccups are awesome. Okay, I need a base. All right, so the area of the base times the height, right? So we got to start off. We got to measure everything we can about this base. For a hexagon, we need the base, we need the number of sides, and we need the apothem. Okay, so ruler, got to measure the base, and the base comes out to, oh, that's so nice. You can't see it, so you're gonna have to trust me. Good thing I never lied about math. It is exactly 3 inches. So the base is 3 inches. Time for the apothem. Try to say apothem with the hiccups. Challenge accepted, Mr. Stevens. Next time I get the hiccups, I'm going to say apothem 5 times fast. Ooh, the apothem here is 2.5 inches. This is awesome. 2.5 inches. Number of sides. Do I need a ruler to count the number of sides? Good answer. No, I don't. 1, 2, 3, 4, 5, 6. 6 sides. And now for the height. Height. Man, they did such a good job making these. Whoever made these, whatever company made, fantastic. 6 inches. Awesome. Height is 6 inches. Okay, now we can plug it all in. If you don't know how exhausting these dang hiccups are by now, ugh. Okay, the hexagonal prism. Excuse me. Since it's a polygonal prism, I get to use the formula for a polygonal prism. Hexagonal prism, we're going to do this one. So the base is 3 inches. The apothem we counted was measured was 2.5 inches. And the number of sides that we found was 6 inches. The height, or excuse me, 6 sides. The height was 6 inches. All that divided by 2. I'm putting these in parentheses because I have a decimal. I didn't want to put dots in between because I had a decimal, so I used parentheses here. Okay, now, here we go. In the calculator, we type 3, not plus, Stevens. Come on now. Let's try again. Here we go. 3 times 2.5 times 6 times 6. All that divided by 2 is 135. Okay. So we get 135 inches cubed. So the total volume for the hexagonal prism that I have is 135 inches cubed. That is cool. All right, we got a couple of examples. I don't know if we have time, but we'll do it anyways. Okay. Couple of examples. Oh, yeah. How do you find the area of a circle? Well, it says here the diameter is 48 inches. All right. So if the diameter is 48 inches for the top, the diameter is 48, then that means so if the diameter is 48 inches, that must mean the radius is 24 inches, right? Cut the diameter in half, we'll get the radius. Okay, and it says that the height here is 56 inches. So the area of this circle times the height. Remember, the area of a circle, recall, is pi r squared, right? So the area of the circle, area of circle is going to be pi r squared. So the volume of a cylinder is going to be pi r squared h. So the volume of a cylinder, pi r squared h. Sorry, I didn't put on the last one. Okay, so for the volume of this cylinder, pi r squared h, what we can do is we know the r here is going to be 24 inches, and the h is 56. So for the volume, we get pi times 24 squared times 56. Use parentheses, be consistent. So throw that in the calculator. Yes, Chase. Throw that in your calculator. I'm going to use 3.14 for pi, and then I have times 24, no, times 24 squared times 56. That's a big number. That's a huge number. Okay, here we go. The volume then is 101,000 with a hiccup, 283.84, what do they say, inches cubed. Volume is going to be cubes. So when it comes to your notation, make sure you say the units cubed. All right, let's do one more just to make sure we're all on the same page. Here I have a right triangle as the base of this triangular prism. All right, so the right triangle, that's cool. So 1/2 base times height. So here's my base, 1/2 base times altitude, right? So my altitude here is going to be 7, right? My altitude 7, my base is 12. So 1/2 base times altitude times the height. Okay, so volume is base times altitude times height, all divided by 2. Okay, that's just another way of doing the 1/2 in front. Either way you do it, it's fine. So my volume here, the base we have is 12. Our altitude is 7, and the height is 19, all over 2. So I can throw that in the calculator. And we get 12 times 7 times 19. All of that divided by 2, 798. So here the volume is 798 centimeters cubed.